1 year is a simple concept on Earth, a cycle of 365 days. Gravity, sunshine, and the rhythms of daily life define it. But in the realm of black holes, time behaves like a trickster. It stretches, contorts, and challenges every assumption. Many wonder how long a year might be near one of these cosmic pits. The question seems straightforward, yet it defies an easy answer. Gravitation in extreme conditions disrupts the flow of time, turning a month into centuries from another perspective. This story explores the puzzle of living near a black hole for what feels like a year. On Earth, a year feels consistent. Sunrise, sunset, birthdays, holidays, and the steady march of seasons. In deep space, that security dissolves. Clocks become relative, tied to gravity and motion rather than a planetary calendar. Black holes stand as the most extreme examples of gravity's power. Their curvature of space-time distorts everything, including how you measure days or years. Observers at different distances record events differently. Each vantage offers a valid timeline, yet no single frame can claim universal truth. That paradox stirs fascination, confusion. It also forms the core of any journey near a black hole. Time is slippery. Physicists use Einstein's general relativity to explain why time bends around massive objects. Near Earth, the effect is minimal. Near a black hole, it's overwhelming. Space and time form a continuum, illustrated as a fabric warped by mass. A black hole is like a bottomless pit in that fabric, pulling everything toward its event horizon. From afar, a falling clock appears to slow down, never quite crossing the threshold. Up close, the traveler feels time flow normally until reality distorts. This discrepancy is the key to understanding how a single year near the horizon can outlast lifetimes in orbit elsewhere. Imagine you're an astronaut named Ortiz. You have a clock identical to one kept on Earth. Both are synchronized before launch. Your destination is a supermassive black hole, a behemoth millions or billions of times heavier than our Sun. Its enormous event horizon could engulf entire star systems. You plan to orbit close to that boundary for what you perceive as 1 year. Meanwhile, Earth observers monitor your mission, comparing your clock to theirs. The difference in elapsed time will be the experiment's highlight, a demonstration of gravitational time dilation at its most dramatic. Travel to such a black hole spans years by normal reckoning. Yet to you, the journey feels shorter due to high-speed travel. Special relativity factors in. Moving near light speed also slows your onboard clock relative to Earth. By the time you arrive, Earth's calendar may have advanced by decades, though you feel only a fraction of that. Still, your real test begins at the black hole itself. You enter a stable orbit where intense gravity warps seconds into elongated intervals. Earth scientists watch your signals, seeing your transmissions slow to a crawl as you skim the brink of oblivion. Your vantage feels normal, heartbeats remain consistent, daily tasks follow familiar patterns, and you mark each day with the same rituals you used back home. Outwardly, nothing suggests cosmic weirdness. Yet data streams from Earth paint a different story. Over there, your clock appears sluggish. Signals from your spacecraft arrive with increasing delay. The difference becomes apparent within weeks. If you promise a progress report every 10 days by your count, Earth might count months before each update arrives. Meanwhile, you're adamant that you transmitted right on schedule. Neither side is wrong. Both interpretations fit the laws of relativity. Back home, people debate how your year near the black hole compares to theirs. Some guess 10 Earth years, others predict a century. The actual ratio depends on orbital radius, black hole mass, and your velocity. In theory, you can tweak those parameters to produce almost any disparity, turning a short stay into hundreds or thousands of Earth years passing outside. Movies often dramatize astronauts returning to a future they barely recognize. That's not fanciful nonsense. It's the logical extension of Einstein's equations applied to a region where gravity reigns supreme. Your daily routine includes system checks, navigation updates, and experiments. You measure cosmic rays, magnetic flux, and gravitational waves. Each day is recorded in a journal. By the time your watch hits 100 days, Earth's calendar might tally several years. News from home arrives in bursts, summarizing breakthroughs in science or changes in politics. Familiar names vanish, replaced by new events and personalities. You feel detached, floating in a bubble of slow time. Your craft orbits steadily, protected by advanced shielding from deadly radiation swirling in the accretion disk, a fiery ring of gas spiraling toward doom. Half a year passes by your reckoning. You've adapted to the darkness, lulled by the silent hum of machinery. Occasionally, you gaze at the black hole's horizon, mesmerized by the light-bending spectacle. Stars appear distorted, twisted into arcs by intense gravity. You also sense subtle threats. Tidal forces, if you stray too close, could spaghettify everything in the blink of an eye. So far, your trajectory is safe. Earth, however, no longer sees you in real time. Each second you broadcast arrives after significant delays. Some watchers might have given up, convinced you're lost. Communication with mission control feels dreamlike. Replies reference events you never witnessed. They speak of fresh technologies, political upheavals, or new environmental data. You realize the place you left is evolving without you. The sense of dislocation intensifies. You reread old letters to ground yourself. Meanwhile, you note that your hair hasn't grayed, your muscles remain toned, and your voice is the same. Yet across the gulf of time, old classmates could be grandparents. Some of them may have passed away. Your year near the black hole has cost you a portion of Earth's story. Days and nights blur in your craft's artificial lighting. The only true constant is your timekeeping. You record each passing day until you hit day 300, day 320, day 340. Earth time, by the best estimates, soars far past what you once knew. The numbers boggle your mind, maybe 15 years back home, maybe more. The specifics hinge on orbital mechanics and your black hole's mass. Emotional toll weighs on you. Each hour you stay, Earth leaps forward. You wonder whether your sacrifice will yield breakthroughs. Perhaps it will transform humanity's understanding of space-time. Finally, your clock approaches day 365. You have completed one full year in your frame of reference. The mission logs confirm your data is comprehensive. You decide to start the departure sequence. Engines fire, plotting a course that frees you from the black hole's grip. Even that exit requires careful calculation. Any slip could toss you inside. Slowly, you peel away from the horizon, returning to a region where relativistic effects lessen. Time between transmissions and Earth shrinks. Your messages begin to arrive with a more familiar delay, a small comfort given what awaits. During the transit back, you notice your body remains biologically 1 year older. Your reflection in the mirror confirms minimal aging. Yet mission control warns that Earth has advanced drastically. You brace for the moment you re-enter Earth's vicinity. The journey home is faster than expected due to advanced propulsion, but Earth's timeline has accelerated beyond anything you remember. Communication arrives in a flurry. New laws, new technologies, entire cultural shifts. The entire solar system brims with innovations that were inconceivable when you left. For you, a year passed. For them, an epoch. Touchdown feels unreal. You step out of your craft, expecting to see familiar faces. Some are there, older, grayer, but alive. Others you never knew. They greet you with awe, calling you a time traveler, though you only feel like yourself. Cameras flash, questions pour in, and the world tries to grasp your story. People marvel at the notion that you lived near a black hole for a single year while Earth spun on, piling up the seasons. Your presence becomes living proof that time can fracture and produce separate realities for different observers. How long was your year? A reporter asks. The question cuts to the core of relativity. You experienced 365 days. Earth's clocks tallied decades, or whatever the final count turned out to be. Each vantage is correct. No universal scoreboard exists to declare one side wrong. Scientists leap at the chance to dissect your data. They confirm that your onboard clock ran consistently in your own frame. Meanwhile, satellites orbiting Earth recorded the unstoppable advance of local time. The disparity aligns beautifully with equations. It's not magic, it's space-time geometry in action. Family reunions are bittersweet. People you remember as children might be married now. Close friends may have departed. A few greet you with tears, relieved you're safe. They've endured your absence for a large fraction of their lives. They speak of your mission like ancient history. In your mind, you saw them only last year. You haven't had the same emotional arc of decades spent waiting or wondering. That gap in experiences can't be bridged easily. You feel lucky to be alive, but also guilty for missing so much. Space exploration demands real costs, measured in lost memories. Your mission data reshapes physics conferences. Researchers analyze gravitational waves you recorded, revealing new details about black hole interiors. They marvel at how signals from your craft slowed as you drew near the horizon. Some suggest the possibility of harnessing these extreme effects for advanced experiments. Others see a cautionary tale. The phenomenon that saved your health, only aging 1 year, also robbed you of life on Earth. You never faced the horrors inside the event horizon, yet the orbit alone had massive implications. A cosmic wonder, but also a personal tragedy. You give lectures at universities explaining that 1 year in a black hole isn't a fixed ratio. It depends on parameters like black hole mass, orbital radius, and velocity. If you had chosen a tighter orbit, you might have returned to find centuries gone. If you'd orbited further out, perhaps only a decade would have passed on Earth. Hollywood loves neat numbers, but reality is more flexible. The main idea stays the same. A year for you can translate into a radically different span for someone elsewhere. Students listen, enthralled, but also uneasy at the notion that time is so relative. Relativity doesn't require black holes to create time discrepancies. Even GPS satellites circling Earth must account for slight time differences caused by lesser gravity and orbital speed. But black holes magnify these effects, turning small corrections into dramatic examples. The horizon region is the ultimate test bed for theories. Nobody can stand at the event horizon and send reports back indefinitely, but orbits close to it push the boundaries of possibility. From that vantage, an observer experiences days in slow motion, at least from the perspective of the universe outside. People ask, is this a path to the future? They imagine parking a spacecraft near a black hole, returning to Earth after a quick trip, and reaping the benefits of advanced technology. In principle, yes. Practically, it's hazardous. The gravitational tidal forces, radiation, and engineering challenges are huge. Surviving near a black hole demands robust design and unwavering precision. Still, the lure persists. It's a tantalizing glimpse of traveling forward through time by leveraging nature's strangest labyrinth. A single orbit can skip you across vast chunks of external history. The cost, everything you leave behind, you try to reintegrate into society. Most of your old bank accounts have matured in unexpected ways. Laws have changed. People use new slang and watch new forms of entertainment. You can't catch up on every detail, so you move through life feeling like a wanderer in a future once unknown. Some admire you as a hero, while others see your displacement as a cautionary warning, an emblem of progress overshadowing personal ties. Yet your presence also expands horizons. Young minds dream of defying time, forging new paths in astrophysics, or exploring cosmic extremes. Over dinners, you recount the spectacle of the black hole's disk. you mention arcs of swirling gas glowing under immense heat, twisted by gravitational lensing. People stare, rapt, imagining the cosmic violence and serene silence combined. They ask if you felt fear. You did. Orbiting so close to an entity that can trap light is unsettling. One miscalculation and you'd plummet inward. The year you spent would become a final dive into the unknown. That tension gave each day an edge of urgency. You never forgot the stakes, even as routine tasks lulled you into calm. When asked if you regret the mission, you hesitate. Part of you cherishes the experience, touching the fringes of reality. Another part mourns the time lost with loved ones, the missed birthdays and life events. Still, the knowledge gleaned might advance humanity in unforeseen directions. That duality is hard to reconcile. The public wants a neat storyline, but real exploration rarely offers neat endings. You encountered the raw mechanics of space-time, and the emotional toll is as real as any equation. You can only say you did what felt necessary. The rest belongs to history. Scientists produce sophisticated diagrams mapping your orbit. They highlight the gravitational well, labeling the region where time dilation hits extreme levels. Your path hugs that boundary for a full year by your clock. Meanwhile, Earth's timeline arcs upward, gaining decades. These diagrams become iconic, displayed in textbooks to illustrate the radical nature of black holes. Students see them and wonder what it felt like. They may never fully grasp the personal weight behind each data point. The smooth lines on a chart gloss over heartbreak, wonder, and sacrifice. Still, the lesson stands. Near a black hole, time isn't uniform. Ultimately, the question, how long is 1 year in a black hole, finds its answer in relativity. For you, it was 1 year. For Earth, it was much more. No single figure defines that gap universally, because space-time doesn't obey a single clock. The deeper you venture into gravity's domain, the more time bends. That truth shapes the universe, from GPS corrections to cosmic journeys. Your story resonates with anyone who's ever wondered whether time is truly fixed. Now, you sit with these thoughts, reconciling what you gained and lost. 1 year changed your life, and Earth's timeline forever.